All right, here's your 7.4 day 2 warm up. So go ahead and take about 5 minutes to work this out. You can go ahead and pause it, and then when you're finished, go ahead and start it up and we'll talk about it. Okay, so those of you that had the new CX calculators, you could go ahead and put this in as a function and it would graph it for you so you could get your table and graph some points. And that kind of stuff. If you have a TI-83 or 84, this is not the case. So I'm going to show you by hand how you could do this. And how I would do it is turn this log into exponential form. So, and we talked about that with our definition of log. So base 3 raised to this exponent, y, is going to equal the stuff inside the log, which is x plus 1. Now I want to get this x by itself, so I'm going to subtract over the 1. So then I get 3 to the y power minus 1 equals x. So this is kind of flipped from what we normally do. So then I'm going to make an xy table of at least 3 points. Usually we plug in the x's and then get the y values. Well, now we're going to choose y values to plug in so that we can get the x values. Now I'm going to just choose -1, 0, 1 as my y values. You can plug in 0, 1, 2 if you want, however you want to do that. So if I plug -1 in here, so 3 to the -1 minus 1 equals x. Now remember, this -1 means that you have got a fraction. That doesn't mean that this comes out to be a negative answer. So this -1 means this is 1/3 minus 1, which is going to be 2/3. I should just put 2/3 here. -2/3. Okay, now I'm going to plug in 0 for y. So 3 to the 0 minus 1. Well, 3 to the 0 power is 1, minus 1 is 0. And then I'm going to plug in 1. 3 to the first power minus 1. So 3 to the first power is 3, minus 1 is 2. So that's how we fill out our table. Once you put it in exponential form, right here, then we're going to pick y values to plug in so that we can get our x values. So now let's graph. So -2/3, -1, about right there, 0, 0, and 2, 1. Okay, now remember that this is going to be an exponential on its side. And so to get the asymptote, once you put it in exponential form, this is your asymptote right here. Remember when we did exponential functions, whatever came after the exponent stuff is going to be your asymptote. Only instead of being y equals, it'll be x equals, because x is over here by itself. So my asymptote is going to be the vertical line x equals -1. So make sure you graph that on here as a dashed line. So here's -1 on the x-axis. So then it's this vertical line at -1. So then when you draw your curve in, remember your asymptote means it's going to get closer and closer to that here, but it's never going to cross. So make sure that your curve doesn't cross. Okay? Now let's do domain and range. Now on this one, range is easy because you will use all of the y values. Since this is an exponential on its side, you'll end up using all the y values, so your range then is going to be all real numbers. Now domain, though, is going to be restricted. And basically you're just going to use your asymptote. So just bring that up here where you have x and your -1. Then look at your graph. Are we using the x's to the right or to the left of the asymptote? And we're only using the x's to the right. So then that's where they are greater than -1. So that's your domain. So your domain is going to follow whatever your asymptote is. You just bring up the x and the number, and then you have to decide if it's greater than or less than. Are you using them on the right, which would be greater than, or the x's on the left, which would be less than? And then how to get the asymptote, remember, if you put it in exponential form like we did here, it's whatever comes after the exponent stuff. Now, for those of you that can just type this in your calculator and you didn't want to change it into exponent form, well, then yours, notice that the asymptote ended up being whatever the opposite that was inside the log. So it looks like +1, but the opposite of +1 is -1, because it's whatever value makes this log 0. So if you just type this in your calculator, those of you that do that and you don't do all the work, well, then know that the asymptote is going to be whatever's opposite of what's in the log. Okay?